Summit Hackathon that I've put some AVAX on there on both the C chain and the P chain.
What wallet are you using?
This is Core Wallet, which is the native wallet of the Avalanche ecosystem. I'm using this because during the process, as you will see, there are some P-chain transactions that can only happen with the Core Wallet, because any other wallet like, I don't know, MetaMask or Rabi, they are not compatible with the P-chain. Okay. And so eventually when you go yourself to the L1 toolbox and it doesn't detect Core installed on your browser, it will tell you to go ahead and install it.
And do it.
So yeah, first step we'll need to do is just create a subnet. So yeah, what is a subnet, you might ask? So subnet was a previous iteration of Avalanche L1s that used to work a bit differently. The way they've done things with the latest upgrade is, in order for your network to become an L1, it has to be a subnet first, and then we'll perform a subnet to L1 conversion transaction in just a while. So as you can see, this is a perfect example. This is actually a P-chain transaction. So from this step with MetaMask, it won't be working anymore. So I've just approved this. This was pretty fast. Second step is to create a chain. So on Avalanche, the subnet can hold multiple chains, multiple blockchains. I think this is probably something that they will stop supporting at some point, because most of the use cases that we have is that each subnet only has one chain. But I don't know. So after creating a subnet, I will be creating a chain that I'll be calling my workshop chain. Chain ID, I will just leave it as it is because I don't really care. For when you guys are building, if you want your chain to have some specific permissions, say that only a list of addresses can perform transaction, or only a list of addresses can deploy contracts, this is something that you can configure in this box here. In our case, we are going to keep everything vanilla and just deploy a regular chain that is powered by subnet EVM, which is a EVM compatible execution engine for Avalanche.
And then with your contract, you can set up specific rules as well, right?
Yeah. So these are the chain rules, in the sense, like I would say at a lower level, like who can deploy a contract, what is the native token named, I don't know, is there some precompiles enabled if you want to access some oracles or some stuff like that. The rules that we will be setting up on the Suzaku side are more
for the validator, right?
Yeah, about the validator management. So okay, I'm done here. I've created the chain, so I'll just follow the tutorial here. Next thing we will do is actually deploy the validator manager contract. So to do that, I don't know if you guys are familiar with Forge Foundry. Yeah. We'll be using Forge because we have done a Forge repo with ready-to-use scripts that are really practical. Without that, it would be quite complicated to use Suzaku, to be honest. Maybe at some point we'll have some wrong tab. Like what the Avalanche team came up with, so just click button interface. We are not quite there yet, so for now it's a bit rough with Forge script, but it's still a nice curated experience. So I've already cloned this. Yeah, so it's basically a repo to clone and install the dependencies. So I've already done that earlier. And the first thing we need to do is create a JSON file that we'll just copy here. I'm going to override what I had. And so at this point, there are a lot of fields in this JSON file, but for this step, just deploying the validator manager contract, there is only 3 fields that will be needed. Is the L1 ID, which we will be getting from here, as well as the churn period and maximum churn percentage. These 2 parameters, I did not mention them. Yeah, you have a question?
So you are deploying to the chain you have just created?
No, actually no. This I will be deploying to the C chain, this contract, because of the reasons I mentioned earlier. And so there are also more reasons to that, is that Most likely the staking tokens that will be used by the Suzaku L1 networks are C-chain native tokens. And so it only makes sense that the Suzaku core protocol is also deployed on the C-chain. This plus the security reasons I mentioned earlier.
But I could deploy to the chain that.
You could deploy to your own chain and make your L1 more sovereign because it will depend on the C chain for the validator manager part. So these two parameters are quite important. Maximum churn percentage is in percent how much the validator manager can change given a period of time. And so by default this is 1 hour. This means that I cannot change the weight of the total weight of the network by more than 20% in 1 hour. This is important because say you have a proof of authority validator manager and for some reason the private key of the admin of this contract is leaked. Someone could remove all of the weight of the current validator and put their own in place. With this churn, in an hour, they will not have the time to do it. And so this gives you time to mitigate, maybe find some issues.
So it's also about the consensus, I think.
Yeah.
If you remove too much of the validator, like the other validators will be lost because they wouldn't know all their peers and they couldn't reconnect and synchronize with them.
True.
So you just can modify a small part of it at a time. Right?
Yeah, you can find yourself in a state where the consensus on your chain is completely messed up, and because you added too much weight at the same time. So like I mentioned, the only thing I need to change here, so these two parameters I will keep by default. And here I need my chain ID in the X format. So I do have it here in the CB58 format, which is a bit different. But thankfully there's a conversion tool here, and I can just convert CB58 to X here. So I will just put that here. And we're actually ready to go and launch this command. So like I mentioned, this is a forge script. There are a bunch of environment variables that needs to be set for contract verification, as well as the private key that you will be using to deploy these contracts. So in this case, I'm comfortable with showing you guys my private key because this is just a dummy key that I created for this workshop, and this is actually the key. That corresponds to the address of the wallet that I have here in core. So I'll be just copying this command, which I've saved here, but it's the same as the one that is here. And go ahead, try to run that. Hopefully it works fine. Can you guys see the screen properly? Yeah, I guess it's fine. Okay, so we are done for the first step. We have deployed a proof of authority validator manager that is ready to handle our chain. So I'll just save the output here because I will need it for later. So second step is, like I mentioned, is to
So in this case, C-chain is the Fuji testnet.
So you have a C chain on Fuji and on the mainnet. C chain is the contract chain. So like I mentioned, it's where most of the Avalanche dApps are deployed and where most of the liquidity is. And so in this case, we are using C chain on Fuji. And so the next step is to actually convert our subnet to the L1. And this is actually the step where we decide where the validator manager lives. So either on the C chain, on the L1, or even on some other L1 if you want. I wouldn't recommend that. And so in the L1 toolbox, we get to decide the blockchain ID of the validator manager. This is actually super well explained in the L1 toolbox, all of these concepts here. So here I'll use the C chain because I have just deployed our smart contract on the C chain. So this is the C chain blockchain ID.
And the other one is the chain that you just deployed, right?
Yeah, exactly.
Okay.
This one is the chain I just deployed, and these are the two, Echo and Dispatch. They have been mentioned by Martin earlier today. There are test chains on the Fuji network to test that they have deployed for ICM testing. So if you guys are building with ICM, probably in the tutorials you will see Echo and Dispatch.
Cool.
So in my case, I would be using the C chain and just copy and pasting the address of the proof of authority validator manager contract address. So this is another big important step, is to add initial validators, right? So during the convert subnet to L1 transaction, you also get to provide a list of validator and their initial weight that will be used for the bootstrapping of the network. I'm not going to do it here, but in your case, what you guys will be doing is going through the node setup step with Docker. I'm going to show you this in another tab.
So we should run some locally, right?
Exactly, so that you run a local node. Again, here
to test the stake and all the procedure, right?
to have a first node that corresponds to the node that we'll be providing in the conversion step. And so in this step, you can run a local node with Docker. It's a super great tool, because then again, I can just select the chain I have created. Well, I need to show this to Owen, he will be happy. But yeah, most likely it will work on the side. So in my case, I will not be running a node because I have already one up and running. I will just query its information. This curl command that I just used, this is the one that they mentioned here. This is to get information about your node. So node ID, public key and proof of possession, which is stuff that is used for BLS signature aggregation when it comes to cross L1 communication. I just said a lot of complicated words, but don't worry about this. So this will be actually the first node, the first and unique node, because at first I will have a proof of authority L1 with just one node, which will be this one. I will just bump the weight, because by default they have 100. We think it's quite low because, like we mentioned, the churn is 20%. So 100 with just 20% weight, if you add another node with 25% weight, then you are already above churn. And so to have more flexibility, we like to make this number a bit bigger. Let's put 1 million here. I think we're ready to go and convert our network to an L1.
Sorry, I wasn't focused. So the node that you just added is running where now?
It's a node that, good question. It's a node that's running on this IP, that is running on AWS on my side. It could be running anywhere.
But when did you start it? Because you just created an L1 chain.
I did it, like this is a testnet node that I have, that I'm using for the sake of this demo. Maybe I should have done with the whole setup with Docker thing, but when we do that, it can take quite some time to synchronize the node locally. So this is why I did not want to do this for this demo, you know. But eventually, by following this step, you end up with a fully functional tested node running locally with Docker. And the command that I just used to get the node ID and info about the node, instead of running it on a remote server like I'm doing now, you're just running it on your local, which is basically the same.
Hopefully.
Yeah. Did I run my convert TX? Yeah, I think I did. Again, this was a P-chain transaction, so only Core can do that. Going back to the documentation, initialize the validator set step. Should I go through this because it's a bit complicated, but in a nutshell, between the validator manager contracts that lives on the C chain or on any other L1, and the P chain, which is actually the registry that is the source of truth when it comes to who is the validator of which L1, there's a back and forth that is necessary. And so this initialized validator set will get some information about the network from the contract, post it on the P chain, take a proof on the P chain, and then put it back on the contract. This is quite complicated. If you want to dig more into this, I think there are some nice docs that I can show you here. Validator. Is that this one? Yeah, that's it. I think that's the one. Probably could mention warp. Yeah, okay. So these warp messaging are the messages that are exchanged between the chain that is hosting the validator manager and the P chain. So like I mentioned, lots of back and forth. This can be quite complicated. If you're interested, I encourage you to be reading this. So in our case, we'll just go and run this step. So we will be finding this here, I think. Set initialize validator set here. So I need the conversion TX ID, which I can find at the bottom of my screen here. Wrong tab. There we go. So that aggregate signature is actually the step where it's querying the nodes that are part of the C chain validators to get the right proof that it needs to post to the P chain. Again, there we go. All right, done with that step. So yeah, as we mentioned here, we have now an L1 that has been created. We have a validator manager that is using the proof of authority implementation. The next step is to migrate this validator manager and upgrade it to the balancer validator manager, which is the Suzaku implementation of the validator manager that I presented you earlier. Again, for this, we have a nice for script that enables you to do it quite seamlessly. So I'm just going to go back to our JSON file and fill out the rest of the fields that we haven't used prior to that. The first command that we ran was only using these fields, and now we're going to use these fields here. So the proxy address is actually the address of the smart contract of the validator manager, which is still this one. I'm going to put that here. Validator manager owner, I'm going to set my own address for this step. So the address of the smart contract that I have here. This one is also important, is when we are migrating to the balancer implementation, we need to have the same total weight that was existing before to be migrated to the balancer. And so this is why it needs to be the same number.
Or higher.
Or higher, yeah. If you remember, what did I put as this number?
1 million.
Yeah, big value, because this is crypto and we like big numbers. There we are. And the latest one is a bit tricky. This is an array of what we call validation ID. When we start a new validation on the P chain, whether it's for the primary network or for another one, you get a unique validation ID. In this case, we have a validation ID that exists for the POA implementation that we have just deployed and that will be migrating to the balancer. And so to get this, we can also use the L1 toolbox. This is actually a custom feature that the dev team have done just for me because I needed it. So thanks to these guys again. I can use this section, query the L1 validator set, select my L1, and then I can see the validators that are currently registered on the P chain for this L1. And if I click on view details, I will be seeing the validation ID that I just mentioned. So in post format CV58 and X. Here we need the X one, so I'll just take this one.
I'm so lost. Okay, cool. It's hard to focus.
It's complicated stuff, yeah. Probably, yes, Suzaku is not the best way to get started on Avalanche, but it's also interesting to see them. I think
so. The P chain is the parent chain.
P chain is for primary chain and
Platforms.
Platform chain, yeah, right. Platform, sorry. And this, you can see the P chain as a registry that tracks all the L1s and all the validators of these L1s. This is like the chain that holds all of this information.
Okay, so it's a validator chain. Yeah.
You can see it as a validator chain. It's also used intensively when it comes to cross-chain communication, because say you have the C chain and you have your L1. When you send a message from the C chain to your L1, say this message, for example, is bridging a token. Your destination chain, your L1, it will query the P chain to know who are the validators of the C chain, and if they can vouch for the message that has just been received, like if this message is legit.
Mm-hmm.
So this is also a situation where the P chain is used. So I set up my fields here. I can just run this command here. Just my screen. Awesome. So at this point, I have migrated my validator manager proxy to a new implementation, which is the balancer validator manager from Suzaku that we developed. Again, saving the output here. And so one last step, and then we'll be done for the demo, is now we are in this situation. Actually, I can maybe go back to the slide to show you, where is it?
It's the last step.
Workshop, that's the one. Now we are actually in this situation, but without this. I'll just delete this quickly. Okay, so say there's not this one. Now we are in a situation where we have the balancer validator manager and one security module, which is just the proof of authority security module with actually only one validator. And so the next step that we're going to do is add another security module, which we call the Avalanche L1 middleware, which is at the core of Suzaku and will be handling the proof of stake subset of the validator manager. So for this, we also have a for script available. And so I'm just going to create a new JSON file that will be used for configuration.
And if I wanted to add a secondary asset, I will just...
This is where it will happen, yeah.
Yeah.
I will go through the fields in just a second. That's where you'll find things interesting.
Yeah.
Again, an owner address, which will be my own address. There we go. Oops. Validator manager proxy, which is still this address. Yes, this I didn't mention, but when we first deployed the validator manager, we deployed it using the proxy pattern. This is because we need this to be flexible and upgradable. Because when we do the convert transaction on the P chain, you only give one address, and so you cannot mess this up. If you give a wrong address, or if you give an address that will be changed at some point, that you will lose control over at some point, you can lose control of the validator manager of your network. So this is why I was using the proxy pattern from OpenZeppelin to be able to change the implementation later.
And then you can add more validators as well, right? Ah, no, but this is just the manager. Okay.
So that's the proxy that's now pointing to the balancer, and then on the balancer you can add more security modules afterwards.
Thank you.
These other fields are actually, these three ones are core contracts of a Suzaku deployment that are deployed and managed by us, the Suzaku team. So one of them is the operator registry on which all the operators can permissionlessly register. And the other two, let's not dig in deep into that for the moment. So this is an interesting part. Every Suzaku L1 has what we call a primary asset, which is the asset that will be used for determining how much weight a validator have. And so in this case, this is an address to an ERC20 contract. We also have a maximum stake and a minimum stake. So in this case, an operator needs to stake or receive delegation of at least one, I think there are 18 zeros behind this. So one full token minimum and maximum 5 full tokens. If they go beyond 5, they will not have more weight. So that's unnecessary.
Where did you take this primary asset address from?
Good question. So this is something that's documented here. Like I mentioned, it's the address of a collateral, which is this one. That is like a mock SRX collateral that we have deployed for testing that can be used in your case, or if you are feeling adventurous, you can go to this documentation and try and deploy your own collateral yourself, of your own token, for example.
Because, sorry, when I launched my L1, doesn't it have a native token that should be used?
It has a native token, but the native token of your L1 is not a smart contract. And so eventually, that's actually something quite important here. When you, what you can do is that, like I think most of the L1s that are live now are using a contract, are using a token that was initially created on the C chain before having their L1 deployed. And so I will give you an example with one of the most used L1, which is Dexalot, which is an order book on chain. They have their own L1. At first, they have created the Allot token as an ERC20 on the C chain. And then they have created their L1. And so in their case, when they have set up the bridge between the C chain and their L1, they have configured it so that the ERC20 is bridged from out of the C chain, and in result, it's minting native tokens on their chain. And so your question was, native token is already existing. Yes and no, because it exists on your chain. In the actually, I didn't show you, but in the create chain step, tokenomics, this is where you can decide what is the total amount of token that exists at the genesis of your network. And so, for example, if you set a big value like 1 million, before you're able to bridge any more assets, you need to fill this first 1 million from the C chain, right? And so if you put a smaller number here, like 1, you just need to bridge 1 token, and then the what is called the initial imbalance will be fixed, and then you will be able to bridge. Not sure if that was clear. Again, there are some great documentation from the dev team on that side, if you're interested.
Yes, I should have, to make it standard way, I should have a token on C chain. Then I'm later going to bridge as a native token to the L1.
That's ideal, yeah. Because if you start the other way around, I guess it could work. I don't see any reason why it wouldn't work. But the most standard way is to go on ERC20 first on the C chain, and then deploy a bridge using ICTT, interchain token transfer, that is configured so that it's locking ERC20 on the C chain and it's minting native on your own.
And somehow, yeah, I'm okay. I won't ask any more questions. Okay.
If you are interested, AVAX, docs, ICTT, yeah, that's the repo, which has been archived. What the fuck? Oh no, now it's ICM contract. Yeah. Best place to find explanations about it. Also bump into the Ave Labs team here. They'll be happy to answer your questions about this. So yeah, to get back on this, this is a collateral. There is a mock SAVAX token that we've created. SAVAX being a liquid staked token of the AVAX on the C chain.
Can we mint that?
You cannot, but if you need a big amount, we can mint it for you.
Thank you.
And so in this case, we're only providing primary assets, but you might be interested in the secondary assets. So it's probably not supported by the script out of the box, but it shouldn't be too hard to implement. Did I mention everything?
Have the same pattern, right? Like
yeah, like I mentioned, this will be the same. What you need to configure is basically this and this. These are the core contracts maintained by us, so that will be the same addresses.
So it will be like secondary asset max, secondary asset min, secondary asset weight.
So for secondary asset, there is no max, there's only min, and there's no weight because the stake to weight factor is only for the primary asset. So if we go back to the earliest example I mentioned to you, you are using dual staking, so requiring operators to stake, say, 1,000 of your native token and 1 Bitcoin. If you say that 1 token equals 1 weight, then if they stake 2,000 of your token, they will have 2,000 of weight, even if they stake 1,000 Bitcoin,
Yeah. Okay.
because they just have to stake a minimum number of 1 Bitcoin, and it will not impact their weight. Only the primary asset impacts the weight.
So you have to add only 2 fields, secondary asset and secondary asset mean.
Yeah.
Thank you.
And so yeah, I just talked about this, but this is important because this is the scale that will convert stake to weight. We'll keep this by default. You want to add something on this, Gauthier?
No, just wondering where this number comes from.
Also wondering. Let's keep that for now. That's the last command, and that was already a lot, I guess.
Yeah.
This is again this is complicated stuff.
Oh my god.
But like it's like this hackathon is a good opportunity for us to kind of also get feedbacks on this kind of stuff, tooling, documentation.
So now you're deploying middleware to the C chain,
yeah,
and
exactly.
it's the last step.
That's the last step.
And I can turn off my brain.
But if I wanted to deploy the validator in my own chain, I will have to deploy the middleware into my own chain as well?
Yeah.
Okay.
And then the only thing that you will have to change here is the RPC URL. Instead of using Fuji, you'll be using RPC to your chain, to your L1.
My local node.
Yeah, local host.
Yeah. 127.0.0.1.
You probably don't want to do that because you would have to deploy also all the rest of the Suzaku protocol. So
I need
better to be a Fuji, no?
Going to be even more complicated.
Yeah. I mean, if it's deploying contracts, I guess I could.
Yeah.
I just need the right parameters.
Yeah. So at this point, we are actually here. So we do not have any POS validator yet, but we are ready to receive those. And so I'm not going to go through it because this will give you some homework. But there's a bunch of other stuff you need to do as an L1, register in the L1 registry, opt in into vaults, stuff like this. This is documented here. So if you're interested in, like, basically one good exercise is just going through everything that we've done yourselves.
Yeah.
If that works, I will be super happy. I mean, you've seen it work, right? Like there hasn't been any issues in my demo.
You skipped some steps.
Yeah, no. What the only thing I didn't do is local node setup.
But Docker is a bitch sometimes.
Yeah, but this I'm quite confident it will be working fine. To be honest.
I will try it today. I will let you know tomorrow.
And then if you have everything here, you can move on to the next steps.
So which one is to add a validator that does the staking? So just which option is it? And I will.
That will be in the operator guide.
The operator. Okay.
Yeah.
Let me.
Then you need to switch your hat, move from being an L1 builder to being an operator.
Yeah. But if I'm an operator, I need to run another separate node, right? Locally. Okay.
Yeah.
So it will be the same IP but different port.